Did you get that? The force should be out of the page for this, if it was a positive charge, and the force should be into the page at this point in time if it was a negative charge. And then vice versa, actually, for down here. And I'll show you why that is. Well, just like before, let's break it up into its components. And this way we can figure out where it's spiraling and also what direction is the force. So that's the components. So based on this, we look for the component that's parallel to the field, which would be the x, just like before. So the spiraling action will definitely be going that way. The component that's parallel is unaffected by the field. So this is the velocity in the y direction that's perpendicular to the field. So you can actually just do your right-hand rule with this component right here, because this is the component that's affected by the field. So velocity, field, force, out of the page. That means the particle is going to move out in a circular motion, but because it has velocity that way, it is going to spiral to the right. And if it was a negative charge, right-hand rule, velocity, field, force, it's lying to you, so it's actually going into the board, x, or velocity, field, force, use my left hand. Left hand is true for negative charges, into the board. So the charge is going to move into the board and spiral. All right, cool. And then if you were to do right-hand rule for this guy, let's see, if you did it for this without breaking it into components, I think it might be a little harder, but you can do velocity, field, it's more straining on your fingers, and then force is out. Yeah, I think for these, it might be easier actually if you just break it up into components and just analyze the perpendicular component. Yeah. Anyways, so down here, I'm going to do the same thing. Boom, boom, boom. Vx, it's parallel to the field, so it must be spiraling that way. We already know that. But the question is it going to be spiraling into the board or out of the board? Well, we focus on the component that's perpendicular to the field. So velocity, field, force, into the board. Thumb is the force. So yep, it's gonna spiral into the board. Wait, it's going down this time. So it's gonna go into the board. Wait, yeah, into the board. Yeah, and spiral to the right. And then if it's a negative charge, use your left hand, or right hand rule's lying to you. So velocity. Oh, wait, no, this guy. Velocity, field, force is coming out. So that is correct. So the charge is going to go down and out, and then spiral to the right. Okay, and if you just did this, I think it's harder, but let's see. Velocity, field, force. Let's see. Yeah, velocity, field, force. It's going into the board for your right-hand rule, so that's correct. If it was a negative charge, if you analyze this, velocity, field, and force out. Yeah, it's definitely more straining if you analyze this one. So just go with analyzing the component that's perpendicular to the field. Okay? So yeah, that is why charges spiral. It's actually kind of cool if you actually think about it. One component is unaffected by the field, and one component is. So you get circular motion because of that component, and this component is like, who cares? I'm not affected, so I'm just going to keep going that way. So it spirals. Okay. Well, I hope that made sense. I'm making this video a little late at night, so yes, hope it makes sense. As always, if you like this video, make sure you like it down there, and I'll let your friends know. That's a great way to help support my channel in this video project. If you'd like to make a donation or anything like that, you can do so on my website, orgomadeeasy.org. I have a tab for donations. I really appreciate it if you do. But if not, thanks for watching, and let me know if you have any feedback, ideas, suggestions, and I'll see you in another video then. Okay? Bye.